Hi students, today let's see some important questions on displacement time graph. So see the first question. From the displacement time graph of a cyclist given in the figure, find the average velocity in the first 4 seconds. Okay. Now see the cyclist is starting from rest. So it is starting from here at the 0 position. Now let's see how much distance he has traveled in the first 4 seconds. So first 1 second he has traveled 5 meter, and then from 2 to 3 seconds he has traveled another 5 meters, and 4 seconds he is somewhere here in between C and D. Okay. So basically he has traveled 10 meters in 4 seconds, and then he is at rest because see the distance is not increasing and the time is increasing. Okay. So average velocity will be total displacement by the total time. Now see the total displacement is 10 meters and the time taken to cover this 10 meter is 4 seconds. So this will be 2.5 meter per second. So this is average velocity. So the answer for the first part is 2.5 meter per second, and this is the average velocity. Now the second part is the total displacement from the initial position at the end of 10 seconds. Okay, now see at the end of 10 seconds. So 10 seconds is here, somewhere here. So displacement at the end of 10 seconds is negative 10 meters. So now the second part is displacement at the end of 10 seconds is equal to minus 10 meters. So this negative sign indicates that the cyclist is away from the starting point in the opposite direction. So this negative indicates the opposite direction. Now see, we can see the cyclist has started from 0, it has moved upwards, and then after 5 seconds he has started traveling downwards here like this. So by the time it is 10 seconds, he has already reached minus 10 meters. So he is 10 meters in the opposite direction. So it will be minus 10 meters. Okay. Now the third part is asking the time after which he reaches the starting point. So now he is at minus 10 meters here. Now after 9 seconds he is again started to travel towards the initial position from where he had started. So he is moving towards the initial position. Now when he was traveling from plus 10 meters to minus 10 meters, in between he has again crossed the initial position, that is the 0 level, and after that he is again traveling back to his initial position, that is after 12 seconds he started traveling towards the original position. So we can say the cyclist reaches the starting position after, see this part, 7 seconds and on the 13th second. 2 times he is reaching the original point from where he had started cycling. So the answer for the third part will be 7 seconds and 13 seconds. Okay, now let's see the next question. So the next question is, the figure shows the displacement of a body at different times. Calculate the velocity of the body as it moves from time interval 0 to 5 seconds, 5 to 7 seconds and 7 to 9 seconds. So this is the displacement time graph given to us, and we have to calculate velocity of the body as it moves from 0 to 5, 5 to 7 and 7 to 9. So from 0 to 5, then from 5 to 7 and from 7 to 9. Okay. So velocity and displacement time graph is given by the slope of the graph, or the velocity, we can say it is the slope of the graph, or it is change in displacement divided by the change in time. So now from 0 to, let's see from 0 to 5 seconds. So 0 to 5 seconds. So what is the change in displacement? Change in displacement will be, for 0 to 5 seconds, change in displacement is from 0 level to 3. So change in displacement is 3. And what is the change in time? Change in time is from 0 seconds to 5 seconds. So it is 3 by 5, that is 0.6. So the velocity for 0 to 5 second is 0.6 meter per second. So velocity is 0.6 meter per second for the first part. Okay, now let's see for the second part. For the second part they are saying 5 to 7 seconds. Now see, 5 to 7 second is this part. So here the graph is a straight line. Okay. So second part is from 5 to 7 second. Change in displacement is at the same level, so 0. And change in time is 5 to 7 second is 2 seconds. This is the change in time. This is also change in time. So for this case, from 0 to 5 seconds we are getting 0. So velocity for 0 to 5 seconds is 0 meter per second. That is, the body is at rest. Okay, now let's see for the third part. Third part is 7 to 9 seconds. So now third part is from 7 to 9 second. Now see, from 7 second is this part and this is 9 second. So what is the change in displacement from 3 to 7? So change in displacement is From 3 he went to 7. So that is 7 minus 3, that is 4. And change in time, 7 to 9 is 2 seconds. That is 2 meter per second. So the answer for the third part is velocity is 2 meter per second. So next they are asking calculate the average velocity during the interval 5 seconds to 9 seconds. So average velocity from this part 5 seconds to 9 seconds. So now what is the change in displacement from 5 seconds to 9 seconds? So it has changed from 3 to 7. Okay. So for 5 to 9 seconds, the change in displacement is equal to 7 minus 3 meters, that is 4 meters. And the change in time is from 5 to 9. So 9 minus 5. So this will be again 4 seconds. So the average velocity is 1 meter per second. So this is our answer. Now let's go to the third question. So the third question says the figure given below represents the displacement time graph of two cars A and B. So this is the figure what they have given. Now we have to find the distance by which car B was initially ahead from car A. Okay, now from this graph we can see the car A is starting from here, the car B is starting from here. So car B is already starting from a distance of 40 kilometer. So the question is asking the distance by which car B was initially ahead from car A. So the answer for 1 will be 40 kilometers. Well, car B is already starting from 40 and car A is starting from 0. Okay. Now they are asking the velocities of car A and car B. Okay, so from this graph we have to find out the velocities of car A and car B. It is a displacement time graph. So again velocity is the slope of the graph, or we can write change in displacement by change in time. So let's find the velocity of car A. So for car A, you see the car is starting at 0, and if we take any time interval from 0 to 2 hours, so this is 2 hours here, so it has traveled 80 kilometers. So change in displacement will be 80 minus 0, as it is starting from 0 and covering 80 kilometers of distance, and the time is starting from 0 to 2 hours, so 2 minus 0. So this is the change in displacement 80, and change in time is 2, so it comes to 40. So velocity of car A is velocity is 40, that is kilometer per time is in hour. So car A velocity is 40 km per hour. Now let's calculate the velocity of car B. So now see, for car B is already starting at 40 and it is going to 80 kilometers in 2 hours. So now change in displacement will be, change in displacement will be 80 minus 40, and change in time interval is 0 to 2 hours, so 2 minus 0, so it is 40 divided by 2, so it is 20. So velocity for car B will be 20 kilometers per hour, because the distance is given in kilometer and the time is in hours. See, the time is given in hours and distance is kilometers. So car A has velocity of 40 km per hour, car B has velocity of 20 km per hour. Okay. So this is change in time. Now see the last part, third part, the time in which the car A catches car B. So now in this situation, see, these two lines are intersecting at the point where the time is 2 hours and the distance is 80 km. So car A and car B, they are intersecting at 80 kilometers, or the time is 2 hours. So the car A will catch B after 2 hours. So the intersection of this graph will give you the solution for this. So the question is the time in which the car A catches car B. So we can say car A catches car B in 2 hours. Car A catches car B in 2 hours. This is the answer. Now the last part, what they are asking. The last part is the distance from start when car A will catch the car B. So they are asking the distance. Here they were asking the time, so it is 2 hours. They were asking the time here. Now they are asking the distance. Distance where the car A will catch the car B. Now see, from this graph we know at 2 hours car A is also at 80 km and car B is also at 80 km. That means in 2 hours car A has reached 80 km mark and car B has also reached the 80 km mark. So the distance from start when car A will catch the car B is 80 kilometers. The last part, answer will be 80 kilometers. This is the third part. Okay. Now let's come to the last question. So the last question says a body at rest is allowed to fall from the top of a tower. Its displacement at different instants is given in the table below. So draw a displacement time graph and state whether the motion is uniform or non-uniform. Okay. So this is the table. This is the time given. And this is the time, and this is the displacement. So accordingly we have to plot the graph. So this is the graph. So when we plot this graph, the displacement time graph, is not a straight line, it's a curved line. So now they are asking, state whether the motion is uniform or non-uniform. So see, for uniform motion, the graph will always be a straight line. And for non-uniform motion, the graph will be a curved line or not a straight line. So for this we are getting a curved line, that is, it is not a uniform motion. So if it would have been a uniform motion, the graph would have been like this. It would be in a straight line like this. So the graph itself shows that it is not a uniform motion. So the motion is a non-uniform motion. This is our answer. Okay students, we'll close this session. So the next part we'll be doing on velocity time graph. This session was on distance or displacement time graph. So next session will be on velocity time graph. If you like this session, please share and subscribe. Bye. Thank you.